Day 815 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 147, insertion sort list. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the head of a singly linked list, sort the list using insertion sort and return the sorted list head. The steps of the insertion sort algorithm. Insertion sort iterates consuming one input element each repetition and growing a sorted output list. At each iteration, insertion sort removes one element from the input data, finds the location it belongs within the sorted list, and inserts it there. It repeats until no input element remains. The following is a graphical example of the insertion sort algorithm. This partially sorted list, black, initially contains only the first element in the list. One element, red, is removed from the input data and inserted in place into the sorted list with each iteration. All right, y'all. So this is just an example of how the insertion sort works, right? So they just grab it and move that one down, move that one down, move that one down, move that one down, and insert it. Boom. So that's basically the algorithm that we're going to be building. As you can see in the examples, all we're doing is sorting this array. Or this linked list. So we have the input head equals an array of integers or a linked list 4, 2, 1, 3. The output is an array of integers or a linked list 1, 2, 3, 4. So all we did was sort this list, but we're not using dot sort or dot sorted. We're using a specific insertion sort algorithm when we write this code. Same here, we're just taking the head, this array of integers or linked list, -1, 5, 3, 4, and 0, and we're just sorting it until -1, 0, 3, 4, 5, right? That is all we're doing. We're just doing it using the insertion sort algorithm. So now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first, we need a dummy node to make inserting at the beginning of the sorted list much easier because every insertion has a node before it. So we're going to say let dummy equal list node, open up the parentheses, and pass in 0. Boom. Then we're going to start with the original head of the unsorted list by declaring a variable called current, and we'll set that equal to head. Boom. Now we're going to process every node from the original list. So we're going to say while let node equal current, we're going to open up the parentheses, and we're going to save the next node before changing any pointers. Otherwise, we lose the rest of the original list. So we're going to say let next equal node dot next. Boom. Now we're going to start searching for the correct insertion point from the beginning of the sorted list. So we'll say declare a variable called prev, and we'll set that equal to dummy. Boom. Now we're going to move forward while the next node's value is smaller than the current node's value. At the end of this loop, prev will point to the node after which node should be inserted. So we're going to say while let next sorted equals prev.next, comma, next sorted dot val is less than node dot val. Boom. Then we're going to open up the brackets and we're going to say prev equals next sorted. Boom. Then we're going to insert the current node into a sorted list by coming underneath this, and we're going to say node dot next equals prev dot next. Boom. Then we're going to come underneath this and we're going to say prev.next equals node. Boom. Then we need to continue processing the remaining unsorted nodes. So we're going to say current equal to next. And then finally, the sorted list starts after the dummy node. So we're going to come down here and we're just going to say return dummy.next. Boom, y'all. Let's give it a run. That should be all she wrote. Let's make sure it runs first. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. And look at that, y'all. 42 milliseconds beats 92.86% of users. Not too bad at all, y'all. So, with that being said, make sure y'all get one more look at the code. This is the whole code right here. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.